Hi everyone. So this next lesson has to do with graphs of functions. And there's a couple of different things we're going to be talking about in terms of graphs of functions. So I've divided the lesson into three parts. It really is all one lesson, but I'll be doing three separate shorter videos kind of covering the different aspects of the graphing stuff that we need to talk about today. So the first thing we're looking at is this here, the finding values from a graph when things are written kind of in function notation. And this first example we're going to kind of work through gives you a graph of months of the year, okay, and the current temperature. So you'll see that I've labeled the months of the year as D. I don't know why I didn't use M. Maybe I was thinking date, okay? So the dates of the year. And then T for temperature. And then if we wanted to write this in function notation, it kind of showed up here. I don't know if it's on your paper, but we would say F of D equals T. So the temperature is a function of the month. So T is a function of, and again for months I use D. And that's what that would look like in function notation. And again, what that's really saying is if you take the date and plug it into this function, it's going to spit out a temperature. Okay, so you can find any date that you want, go up to the graph and find the temperature that corresponds with it. Now, the one thing that I would like to do on this example, and I wish that I had done it before I copied it for all of you, is instead of calling these January, February, March, just so we're working in number land, I'm going to number the months, okay? Okay, and so then later on in the problem when I refer to, 5, that refers to May, okay? So like for example, in this first one, evaluate f of 6. Again, this is always going to be your independent variable. So this is giving you like the x value, or in this case, the d value. So f of 6, I'm going to find month number 6, and I just want to read off the graph. What is that value right there? And we can kind of estimate, I would say maybe approximately 75, right? If you called it 74 or 76, that's okay. Okay? And what that means is that in the month of June, how do I want to say this? June temp is 75. And I think these are, so this is temperatures in Central Park in a given year. So at the beginning of June, because each one of these represents the first day of the month, at the beginning of June, the temperature in Central Park was 75 degrees. Okay, so evaluate f of 4 minus f of 2. Well, f of 4, that would be here for April. Okay, so I'm going up to the graph and then reading straight across. And I don't know, what do we want to call that? Maybe 53? Okay, again, if we disagree, that's okay. F of 2 would be here, and it looks like we had a little temperature dip there, and that would be maybe 35 or 36. I think I'll go 36. And then remember that sign in the middle really is a subtraction sign. Some people get really thrown by that, but I'm really just doing 53 minus 36, and that comes out to be 17. So let's think about what that 17 degrees represents, okay? And just the fact that it's degrees is probably helpful, but that 17 degrees represents the change in temperature from February to April, okay? So we could say something along the lines of the temp increases, because it came out positive, by 17 degrees from February to April, because those are the 2 months we were working with. Okay? And our last one. We did one very similar to this in the homework yesterday. I think I'll shrink this so I can get the graph on the screen. We didn't do it off of a graph. We did it just out of a table of numbers, but I think you're going to get the same kind of idea from this. So f of 12, that's my December temperature, and I'm going to call that maybe 38. So this is meaning to do 38 minus f of 8, which that's August. F of 8 would be here. Let's call that maybe 86. And then on the bottom, I'm really just doing 12 minus 8. So 38 minus 86 comes out negative, and the reason for that is you're taking a lower temperature and subtracting a higher temperature. That means that from August to December, my temperature is going down, and that makes sense, hopefully. Okay? And then 12 minus 8 is 4. And so let's just think about what this value is really saying right now. I'm going to move this up so you can see it. This negative 48, that means that the temp dropped from whatever months I was just talking about. From August to December. And then think about, why would we take that temperature drop and divide by 4? Okay, because when we divide by 4, we get negative 12. What that negative 12 is really telling us is the average change per month. So I took the total amount that it dropped and divided by the 4 months, and I can say on average, the temp drops by 12 degrees per month. I don't know why I went with a P. Okay, that's what that last one is really talking about. Okay? And this last one, domain and range of this function. There's a little bit of interpretation here, okay? Every year I kind of have this debate. Domain is, what are your possible independent variables? And if you're very literal, you're going to look at this and you're going to say, well, my possible independent variables go from January to December, or 1 to 12, okay? So we could say the domain is all the months from January to December. Okay, numerically that would be all of the whole numbers from 1 to 12, okay? But they represent the months. Now, some people make the argument that this graph would keep going, okay, that this just represents 1 year, but they sort of interpret it as there's arrows on the end of these, and this graph is going to keep going. Now, the only problem with that is we don't know that it's going to keep following the exact same pattern, so we can't make any assumptions about what happens beyond the scope of this graph. But some people have tried to argue, well, it would just be any month of any year. Okay, all months would be your domain. And I think you could make that argument for sure. This is sort of a weird one because it's a real life situation, not just numerical. Okay, and then for range, it also depends what you're calling, what you're saying is happening with this graph. Probably what I would do is I would be very literal. I would look at my y values, and you could say all temperatures, something like that. But because we can say specifically the lowest temperature is here and the highest temperature is here, we could say it's all temperatures between this and this. And actually, it's hard to tell. No, I don't think that's any lower than that. So I could kind of set my range and say it's all temperatures between from 36 degrees to, let's see, what did we call this one a second ago? I think 86 degrees. Okay. Sorry, you can't even see me writing that. So 36 degrees to 86 degrees. Again, quite honestly, if you try to make the argument that it's all possible temperatures as your range, I think you could make that case for sure. But usually with graphs, if we can see a definite low point and a definite high point, we list the numbers specifically. Okay. But I just kind of wanted you to get used to reading data points off of a graph using this function notation. That's really all there is to this. This piece of the lesson should not be too difficult at all.